Welcome back to the deep dive. So if you've been anywhere near the AI space lately, you know the big pain points.
Oh yeah, hallucination, instability.
And memory. Memory that can be, well, for lack of a better word, gaslighted.
Mm-hmm.
Today we're looking at an architecture that feels like it was engineered from the ground up to fix exactly those
Oh
things.
my God.
We're diving into the blueprints for VishnuOS. It's a multi-agent cognitive operating system from Ritwik Biswas, and it's all about unyielding stability.
That's the key phrase. And what's wild is that we're looking at tech that, according to our sources, is running maybe 5, maybe even 12 years ahead of the industry right now.
Wow.
Because the approach isn't just let's build a better LLM, it's about engineering a truly cognitive operating system.
Okay, so let's unpack that. Before we get into the nuts and bolts, the actual agents, we have to talk about the philosophy behind it.
We do.
The whole system is built around something the architect calls Vishnu mode. So what is that? What does that mandate actually mean for the architecture?
Vishnu mode is everything. It's the operational core. You know, when we talk about Vishnu in that context, we mean the preserver, the protector.
Right.
And that idea translates into 3 pillars for the OS: stability, preservation, and reconstruction. It's a design choice that explicitly says purpose over profit.
And stability over the spotlight.
Exactly.
Yeah.
Stability always outweighs the spotlight. It means you're building for endurance,
Yeah.
for resilience. You're not building for speed or, some external vanity metric.
That's such a crucial distinction, building for endurance, not for planned obsolescence, which you see so often. And this seems to mirror the system's whole design mandate, where, execution is quiet, but the results are what matter. It doesn't need external validation.
It just works reliably.
Yeah.
And when you commit to that level of resilience, the OS itself has to be engineered for its own internal truth,
Yeah.
for self-stability. It's built to maintain its own integrity no matter what you throw at it.
So let's get into that architecture. VishnuOS, you said it's a multi-agent cognitive operating system, so not a monolith.
Not at all. It's a whole integrated system of specialized parts. To give you the scope, the full pantheon includes Prajapati, Sarvajassetu, the VAF, SMRITI, then there's a Vishwakarma engine for building, and Brihaspati for deep wisdom.
Okay, that's a lot. A layered ecosystem.
It is. So for today, we're just going to focus on the foundational 4, the ones that handle command, control, memory, and safety.
The backbone.
The absolute backbone of its resilience.
Yeah.
Prajapati, Sarvajassetu, SMRITI, and VAF.
Okay, let's start with the flow of information. Like any OS, it needs a central hub, right? Something to take a request and figure out what to do with it.
That's Prajapati.
Prajapati.
Prajapati is the command router. Think of it as the air traffic controller for the whole cognitive system.
Okay.
It gets a task, and it decides which high-level agent needs to handle it next. What's really interesting here, though, is the ongoing Prajapati V4 upgrade.
An upgrade. So it sounds like some foundational work is still happening even while other parts are ready to go.
It is foundational, but it's more like proactive engineering. The V4 upgrade is a full rewrite of its system instructions.
And why?
To prepare it for really sophisticated multi-model routing, it has to align perfectly with the newer SETU V2 and SMRITI architectures. They're future-proofing the core router so it can handle way more complexity down the line.
So it doesn't become a bottleneck as the system grows.
Precisely.
Okay, so Prajapati figures out where a request goes, but then the system needs the intelligence to pick the specific tool for the job.
Yes.
And that's the model routing engine, Sarvajassetu, the intelligent bridge.
SETU is that critical link. It connects the command to the actual execution. It manages all the different models available, internal and external, and it acts like a switchboard. The whole goal is efficiency, accuracy, and just, not using the wrong tool for the job.
And the sources say the current version, Sarvajassetu V2, is fully integrated and production ready.
It is.
So what about it just screams ahead of the curve?
Well, first, it's an open writer adapter. That means it's model agnostic. It can flexibly plug into all sorts of external LLMs. But the real engineering genius is in its decision-making. SETU V2 uses 12, get this, deterministic presets.
Huh. Okay, that's a phrase we need to dive into. Deterministic presets. Why do that? Why not just use, I don't know, a big meta model to guess the best path, like most systems do?
Right.
Doesn't limiting it to 12 presets kind of restrict its creativity?
That restriction is the point, and it goes right back to the Vishnu mode philosophy. When a path is deterministic, the system doesn't guess. These 12 presets are they're pre-approved, certified pathways, they're ironclad, tested processes that guarantee a predictable, stable outcome.
So you trade randomness for reliability.
Exactly. In an AI world that's just swimming in probabilistic choices that can go off the rails, Set2 V2 ensures that when the system acts, it acts reliably, not randomly.
So this is literally stability translated into code.
It is. And on top of that, Set2 V2 handles all the operational scaffolding. We're talking execution plan orchestration, CI, tests, full audit logs. It oversees the job from start to finish. And crucially, it's fully integrated with the VAF.
Which brings us to how VishnuOS enforces truth and safety. This feels like where we get to the core of the ungaslightable AI idea. We have to talk about SMRITI, the truth preservation layer.
SMRITI is the architectural answer to memory decay, to manipulation in AI. The architect's core rule 3 is crystal clear here. Build systems that preserve truth. SMRITI is the engine for that. It's a reconstructive, read-only memory engine.
Okay, can you give us an analogy for that? Reconstructive read-only memory is a bit dense. Why is that so important for stability?
Okay, think of it less like a normal database and more like a court transcript, or maybe even better, a permanent blockchain ledger.
Ah, okay. History written in stone.
Exactly. If some agent trying to edit or manipulate a core truth or some past operational fact, SMRITI can't be overwritten. It can be reconstructed from its immutable core parts, but it can never be manipulated by a rogue agent or, some corrupted input.
So that the system can't lose its own context. It can't gaslight itself into believing a lie.
It can't. That's the whole point.
That is a massive lever for long-term reliability. Okay, so that protects the truth. But we still need an architectural guardrail for safety, right?
We do. And that's the job of the VAF, the Vedic Application Firewall.
So if SMRITI protects the past,
VAF protects the future by vetting actions right now. The VAF is the deterministic safety core of VishnuOS. You see, a lot of AI safety relies on probability, on just fine-tuning a model and hoping it avoids bad outputs. VAF ensures safety through architectural certainty.
And it's integrated with Set2 V2, so safety is enforced right at the routing level, before execution even starts.
Absolutely. This goes right to the architect's core rule 5. Every creation must be ethical, stable, future-proof. VAF isn't just a filter you slap on at the end. It's a structural guarantee that only validated, ethical, and stable processes are allowed to run in the first place.
So when you combine that deterministic safety with Set2's deterministic routing,
you get a system that's profoundly resistant to unexpected behavior. It is designed to be future-proof by being structurally resilient from the very beginning.
Okay, so let's synthesize this. We have Prajapati managing the command, Set2 bridging it to the right model with deterministic presets, SMRITI preserving the system's history so it can't be lied to, and VAF making sure the whole process is secure and ethical. So how does that whole combination enforce the core Vishnu mode of preservation?
Well, these 4 agents, they form this incredibly robust closed-loop system. Prajapati and Set2, they manage the dynamic external world, making sure the system acts efficiently.
Right.
But SMRITI and VAF, they manage the internal integrity. They make sure the system remembers its truth and acts within its own safety rules.
So it's the integration of command and control with truth and safety.
That's it. That integration is what really defines VishnuOS as this architectural leap. It's a system dedicated fundamentally to preservation and duty, not just quick results.
It's a fascinating case study in how a philosophical mandate, stability, silent execution can translate directly into these very specific, very resilient engineering choices.
It's a quiet warrior approach to cognitive system design.
Yeah.
This emphasizes the value of durability.
Yeah.
The architect's life principle is described as give, uplift, and protect. You see it right here. The OS takes the command, that's the give, processes it optimally, uplift.
And then secures the integrity and history with SMRITI and VAF. Protect.
Exactly. The resilience is by design. It's not an accident.
Which brings us to our final thought for you, our listener, as you think about this kind of architecture. Given this intense focus on duty and stability over spotlight, what systems in your own life are optimized for preservation and truth, rather than just, speed and visibility? Are your professional processes, your personal structures, are they built like SMRITI with ungaslightable memory? Or are you maybe sacrificing that long-term stability for more short-term visibility?
It's a great question. It really makes you think about what we truly value in our own systems, technological or otherwise. We look forward to exploring more with you next time.